we have some comments about Laplace transforms. So some comments. First comment is the infinite integral of f of t. The infinite integral of f of t. That is integration from 0 to infinity f of t dt. This integration need not exist. For a Laplace transform to exist. Because even though this integration does not exist, the Laplace transform may exist. The Laplace transform of this function may exist. This is what we want to say. For instance, f of t may diverge exponentially. For large t. For large values of t, this function may diverge exponentially. So this integral might not diverge, but still the Laplace transform may exist. However, if there are some constants, what are those constants? S0, capital M, and T0, which is greater than or equal to 0, such that for all values of t greater than T0, the modulus of e to the power minus S0t ft is less than or equal to m. The Laplace transform will exist for the values of s greater than S0. In such case, the function f of t is said to be of exponential order. Is said to be of exponential order. Okay, so what have we discussed here? We have a function f of t whose infinite integral does not exist. But if we can find some constants s naught, capital M, and t naught such that the magnitude of this product is less than or equal to capital M for values of t greater than t naught, then in such a case, the Laplace transform of the given function f will exist. Okay. So in such a case, the function is said to be of exponential order. Let us have a counter example here. Counter example number 1. F of t equal to e to the power t square. This function does not satisfy the above condition. This function does not satisfy the above condition and is not of exponential order. It's not of exponential order. Thus, the Laplace transform of function e to the power t square does not exist. The Laplace transform of this function does not exist because this function does not satisfy this particular condition. Second case, the Laplace transform may also fail to exist. I repeat, the Laplace transform may also fail to exist because of a sufficiently strong singularity in the function f of t as t tends to 0. I repeat, the Laplace transform may also fail to exist because of a sufficiently strong singularity in the function as f of t tends to 0. For example, integration 0 to infinity e to the power minus st t to the power n dt diverges at the origin. At the origin, that is t equal to 0. Diverges at the origin, that is for values of t equal to 0 for n less than or equal to minus 1. This integration diverges at the origin for n less than or equal to minus 1. Therefore, the Laplace transform of the function t to the power n does not exist. For n less than or equal to minus 1. This is another example where the Laplace transform fails to exist. Okay. Let us look at one example of Laplace transform. Example of Laplace transform. First example is let the function f of t be equal to 1, where t is greater than or equal to 0. That is, I have this function f of t, and this function is equal to 1 when t is greater than or equal to 0. Then the Laplace transform of this function, that is the Laplace transform of f of t. This is nothing but the Laplace transform of 1. This is equal to integration 0 to infinity e to the power minus st f of t. And what is f of t here? F of t is 1. When you multiply e to the power minus st by 1, we get e to the power minus st dt. So this is the Laplace transform. And what is the value of this integral? The value of this integral is e to the power minus st divided by minus s, and the limit is 0 to infinity. Okay. And what is this? This is equal to 1 upon s. See, 0 is half. So when you put t equal to 0, this becomes e to the power 0. And what is e to the power 0? 1. Power 0 is 1. Then the second would be when you put t equal to infinity. That is when limit t tends to infinity, e to the power minus st. I have taken the denominator s out here. Now t tends to infinity, e to the power minus st. This limit will become 0 if s is greater than 0. If s is a positive number, then this limit will be 0. And if s is a negative number, then this limit will be infinite. So if I take s greater than 0, then this becomes 0. Sorry, yes. When I take s to be a positive number, then this becomes e to the power minus infinity, and e to the power minus infinity is 0. Therefore, this is equal to 0. So I have only 1 by s. 1 by s where s is greater than 0. So for those values of s greater than 0, this limit exists and it is equal to 0. Therefore, the Laplace transform of the function f of t equal to 1 is equal to 1 by s for values of s greater than 0. Therefore, Laplace transform of 1 is equal to 1 by s for s greater than 0. That means the inverse Laplace transform of 1 by s will be equal to 1. There we go. So this is simple. Let us look at another example. So this is example number 1. Let us look at example number 2. Example 2. What is the Laplace transform of the function f of t equal to e to the power at? What is the Laplace transform of this function? So let us calculate the Laplace transform of this function, e to the power at. This is equal to integration from 0 to infinity e to the power minus st e to the power at dt. This is equal to integration from 0 to infinity e to the power minus s minus a times t dt. I have combined these two exponent terms. Now this is equal to integration e to the power minus s minus a divided by minus s minus a, limit 0 to infinity. And this is equal to 1 by s minus a. You put, I should have a t here. When you put t equal to 0, this becomes e to the power 0, that is 1, minus limit t tends to infinity, e to the power minus s minus a times t. This is somewhat similar to our last example. So I have e to the power minus s minus a times t, and limit t tends to infinity. If s minus a is a positive quantity, that means if s is greater than a, then in the limit t tends to infinity, this limit becomes 0. Otherwise, if s is less than a, if s is less than a, then this limit diverges when t tends to infinity. So let us take the case when s is greater than a, so that this Laplace transform exists. So this Laplace transform exists only for those cases when s is greater than a. And so when s is greater than a, this limit is 0. So what do I have now? I have only 1 by s minus a. When s is greater than a. That means the Laplace transform converges for all values of s greater than a. And for s values and for those values of s less than a, the transform does not converge. So the transform converges for only for those values of s greater than a. Therefore, Laplace transform of e to the power at is equal to 1 by s minus a. Therefore, the inverse Laplace transform of 1 by s minus a will be e to the power at. Okay, so that's all for today. Let me stop the recording.